name's JD Wolverton. I'm the sales engineer at Winter Engine Generator. Today I'm going to go over some basic uses of the Kohler Power Solutions Center, which is our sizing software for Kohler generators. And here we go. Okay, today we will be going over a quick introduction to the Power Solutions Center by Kohler. It is a web-based application. Here's your website for getting into it. Now when you first log into this application, you're going to have to register. Register process is not difficult. It doesn't take very long. After that, you'll be able to enter your email and password and get into the application. The very first thing that comes up when you go into this application is a list of projects that you're working on. If you see any that are outlined in brackets, those are ones that other people have sent you to take a look at or sent you to work on. We're going to make a new one just to see how it's done here today. Create a new project. We'll go with Sizing 101. Customer name. Customer contact. Alright. Description you can add if you need to, and then save the project. Once you save the project, it'll ask you if you want to start. I'm going to go with yes. First thing that comes up is a blank screen with a single generator. Your menu buttons are over here. Your loads are running across the top of the display. You have a small menu up here that gives you the name of your project, language, and units, and your application menu, which gives you save project, send, detailed report, etc. Over here on the right side of the screen, we're going to set up our generator. For most all applications that I've seen come across, we'll be dealing with stationary emergency. I have done a couple prime powers. You can do non-road mobile, Tier 4 stationary emergency, fuel optimized for HVO, things of that nature. So we're going to leave it with stationary emergency, US EPA. Voltage, we're going to leave it 277/480, 3-phase. Those can be changed. Temperature, we'll leave it at 130 degrees, standby unit. Quantity is going to be one generator. Now if you were doing paralleling or something of that nature, you could always change this. Altitude, 500 feet is good for here at the shop. Ambient temperature, 77. The ISO 8528, we'll get to in a little bit here. We're going to leave this as it is for right now. Down here you'll have your specifications for your voltage dip, your frequency, total harmonic distortion, fuel type, minimum load, and maximum capacity load. These are the numbers that come from Kohler. We don't want to see at max any more than a 30% dip in the voltage, 20% dip in frequency, and 10% harmonic distortion. We're going to leave this as a diesel engine, although you can change to natural gas, LP, or dual fuel. Kohler's version of dual fuel is LP vapor and natural gas. We're going to leave the 30% minimum, 80% maximum. Down here you can adjust for your UL 2200, your seismic, etc. So alright, application. Let's set this up as a data center. Alright, down here in this view down here you'll see a small window which will give you an overview of your one line. This is where you're going to generate your one line at. Some of the things to take into consideration for sizing the unit are going to be your altitude and ambient temperature, high ambient temperature, low operating temperatures, your ISO performance class, which will actually regulate your frequency, voltage, and transient dip requirements, load factor, minimum load requirements, and maximum load requirements if you're planning for expansion. So Let's go ahead and learn some of the other stuff on the desktop here. Your settings will take you back to your screen where you created your project. Your load profile will be your one line along with the information about each load or your generator over here. Select genset we'll be using after we fill out our loads. Additional tools. If you click on that, across the top, you're going to get the additional tools settings. Right here's all your settings for this menu in particular. You have a sound level calculator, so you can go with, let's say, a 50 kW diesel. And let's say we're at 23 feet, which is our standard for taking sound readings. It'll tell you at 23 feet with a weather enclosing, you're going to be at 79.7 decibels. And sound level 2, you're going to be at 64.6 decibels. If we wanted to know an exact measurements, let's say 10 feet from the generator, it'll give you your 23 feet still, which is your industry standard, and it'll also give you 10 feet from the generator, what you're going to hear. Exhaust system piping calculator. This, if you throw in your model generator, along with your silencer dimensions, your flow, which all this can be found in the spec sheet for the generator. Although I think if you click on one, it'll automatically fill all this in for you. Your exhaust temperatures, your allowable back pressure. Over here, if you know the length of pipe that you're going to run along with your bends, it'll give you your minimum recommended pipe size along with the specs for that exhaust system. This calculation is for open units only. This does not work with enclosed units, units that you're looking to extend an exhaust up the side of a building or something of that nature. The gas fuel pipe sizing calculator is currently not available. It's being worked on, so that should be out soon. Genset room size calculator. This one, again, is for indoor units. If you pick a generator, it'll give you the minimum requirements for the room, along with your specs over here for the exhaust height, incoming and outgoing louver sizes, and how far above grade. That's pretty much all that's here. Request assistance and request quote. I can tell you if you're in our area and you fill out either one of these, your email is going to be coming to my desk and I'll be getting a hold of you. Alright, let's go back to our load profile. Here's your lighting loads, your battery charging loads, office equipment, miscellaneous linear loads and nonlinear loads, UPSs, medical equipment, welders, motors, air conditioners, fire pump, elevators, transfer switches, transformers, and circuit breakers. The ATS, transformer, and circuit breakers don't hold any significant changes to the generator system. They're basically here for your one line to be able to separate steps and things of that nature visually. Alright, first thing I'm going to do is I'm going to drop down an ATS on my generator. When I do that, it comes up with a description box and amperage. Let's make this LS for life safety, and we'll give it 104 amp. When we do that, here's your label for your ATS along with the amperage of it. From here you can copy this and you can delete it as well from this interior box. Over here, as we zoom out, you can move this around, your cursor around, and move around using the actual overview down here. You can also grab the screen anywhere, drag, and it'll move things around for you also. So let's start with some lighting load. I'm going to drag some lighting load into the ATS. When you drag over lighting loads, the first thing that'll come up is your description box. Just going to put lighting in there for now. It'll do steps. You can add quantities of lighting. You can dictate how your lighting is wired precisely, your voltage of your lighting, which should, for intensive purposes here, match your generator. If we had a transformer in there, that might change. You can do your kW, kVA, or amperage. I'm going to go with amperage. And let's say running amps on this is 30 amps worth. You can add harmonic filtering to your lighting. It'll also ask you what type of lighting you're going to be doing: incandescent, HID, fluorescent, or LED. Let's go with LED lighting. And we're going to go with filtered ballast for now, for the driver. Down here in advanced settings, you can actually set all the specifications for your lighting individually in terms of harmonics, power factor, load factor, things of that nature. And down here it will give you your calculations for running and starting load. Now if we just have 30 amps of LED lighting on this generator, if we were to go to our select genset, it's going to give us a 40 REO-ZK with a 4P7BX alternator. If you'll notice, the one below it is only at 47.5% loaded as well with a 4P5X. The problem is we exceed our harmonics with this alternator on it. Right here with the one that's the computer has chosen is 9.7%, which puts us under our 10% total harmonic distortion. If we chose the other alternator, we'd be at 15.1%, which we don't want to go anywhere over 10%. It can do a pretty decent amount of damage to the generator. And changing your ISO performance classes. We have G1 through G4, G1 being the general purpose applications, 25% voltage dip, 15% frequency dip. G2 is your commercial public utilities, 20% voltage dip, 10% frequency dip. Class 3 or G3 is your telecommunications systems, 15% voltage dip, 7% frequency dip. And Class G4 is actually user determined, which is what we have it set on right now. All right, let's go back to our load profile. Let's add another transfer switch to it. Drag it down, drop it on top of the generator. It'll automatically populate it in the screen. Let's make this one mechanical. And let's make it an 800 amp ATS. Now let's say we have a 25 horsepower motor that we want to put on our generator system for sizing. We're going to drag it down, drop it on our ATS. It automatically brings it up. Let's say it's a paddle motor. Step 1, quantity 1, voltage 277, 480. Let's go with 25 horsepower. 3-phase, it'll automatically populate motor code G depending on your horsepower and voltage and everything. Across the line start, here you can choose to add a VFD, soft start with ramp, VFD with ramp, Y delta closed or open. You can put just about any starting instrument that you want on them. I'm going to leave it as across the line right now. Actually, I'm going to go VFD with ramp. Leave it at 6 pulse. Loaded or unloaded. Unloaded motors are, some examples might be centrifugal blowers, centrifugal pumps, rotary pumps, clutched and fan motors. Your loaded motors are going to be your rock crushers, your elevators, conveyors, compressors, submersible pumps, things of that nature. You can also choose to put your harmonic filtering on motor loads, as well as change your advanced setting. You can dictate all your information about the motor itself, and it'll also give you the running and starting information down here. Alright. If you scroll in and out with the scroll wheel, you'll enlarge and shrink your display. Alright, on top of that, let's add all miscellaneous load. We'll leave that as 3-phase. Let's put 20 kW worth of miscellaneous load. Let's go over and select our genset. See what it gives us. We're up to an 80 kW, and we're running at 75.4% of our maximum capacity, or the rated capacity of the generator. 9.3% total harmonic distortion, 2% frequency dip, 6% voltage dip, 385 max starting kVA, 99 max starting kW. Now, just because this comes up as the optimal genset, let's say I wanted under 6% total harmonic distortion. This unit that's up here will work just as well. It's only at 41.7% loaded, which gives you some room for expansion, but now you're under your 6% that you wanted for your total harmonic distortion. Let's go back to our load profile. Now the other thing that we can do, let's say we have a fire pump. I'm going to drag a fire pump down and run that directly off the generator, because it would initially have its own controller. Kohler does not make a fire pump controller. They usually come with fire pumps. Whenever that goes in, let's say it's 50 horsepower fire pump. I always leave this across the line just because I want to know that that fire pump will start up even if the starting system on the fire pump fails. So if a VFD fails, I want to know that across the line this fire pump will still start. Now when I do this, and I go over to choose my generator, now I'm up to a 200 kW. And the reason for that is whenever you choose a fire pump, the software automatically lowers you to the NEC dictated 15% voltage dip on the generator. And it will actually reflect that in the generator that it chooses. So anything above that will exceed the voltage dip up to a 350. A 200 will do it with this rear end on the 200. You're at 51.8% loaded, 3.5% total harmonic distortion, 3% maximum frequency dip, and 14% maximum voltage dip. Go back to our load profile. Let's put an air conditioning system on another transfer switch. So we're going to drag and drop another transfer switch. We're going to make this one HVAC 1. We'll give it 260 amps. And I'll drag and drop an air conditioner onto it. It's asking for tons. Let's go with amperage. Let's say we're running 60 amps on the AC unit. And give it, let's leave it on across the line start on that one. Now, let me drag down another air conditioner to it. And let's make this one 100 amps. Alright, let's go pick our generator. Currently we're sitting at a 350 REOZJC with a 4M4019 alternator. 41.6% loaded, 2% distortion, 2% frequency, and 10% voltage dip. So right now we're sitting at a 350 with a 4M4019. One of the things we can do to lower the size of our generator is we can step these into separate steps. So let's say we time them and we'll put the first HVAC on step 2 and the second HVAC on step 3. This will then time the units so that when the generator fires up, your transfer switches kick over, and then after a specific time delay, the first HVAC system comes on and then the second one. Let's select a genset. Now we went from that 350 back down to a 200 just by putting time delays on our HVAC. Go back to our load profile. Office equipment we don't use very much. If you call in to me and you ask me to run a sizing report for you, it's very rare that I run one with office equipment. I usually either pick miscellaneous nonlinear or linear load for linear load for static loads like resistive loads. If we want to put a load bank on this unit, let's say we want to put let's say we want a minimum of about 60% runtime or percentage on it. Right now we're running at 72.9, so we're doing good there. Let me eliminate something real quick and see what comes up. Load profile. Let's get rid of the HVAC units by clicking on the delete button. This ATS also. Let's see what we got. 251%. Okay. Load profile. Let's add a single motor load to it. And let's make it a 50 horsepower. Select our genset. Now we're only running at 41.3% load. If you wanted to get to 60, you would need 20% of a 350 and a load bank. Let's throw a 100 kW load bank on it. Profile, miscellaneous linear load. I'm going to put load bank. Let's put 100 kW. Let's put an 80 kW one, just so I don't go over. I want to drive us into the next generator bracket. Select a genset. Now your 350 is running over your 60% requested load. That's where you would use your miscellaneous linear loads. All the other loads are pretty self-explanatory. Elevators, very similar. Just throw an ATS on it. Throw an elevator on there. Oh. Okay, let's go with horsepower and let's make it a 10 horsepower motor. Just for, oops. Select genset. You're at a 400 now at 58.3%. If you were doing this as a sizing as an engineer, now you could on the fly, if you still wanted to maintain 60%, go back and all you would have to change is the amount of your load bank. To bring it back up above the 63%, if that's what you were looking or shooting for or aiming for. Now, if I wanted to run a load bank report on this, let's say an engineer contacted me because we are selling a generator, and they say, hey, I need you to provide a load bank or a sizing report for your generator to make sure that it handles everything that the generator we have spec'd handles. If I wanted this one right here, the one that it comes up with is optimum, I would select it. If you left click on any one of these, you can select the generators. Go up here to create a project report. We always use a detailed summary. So a summary will give you a very basic one, a single page. It says, hey, it'll work, hey, it won't work. If you pick the detailed report, it will give you all your different loads. It'll tell you exactly how the loads are working with the generator, things of that nature. So I'm going to download that report. And it's going to ask me where I want to download it to. Save it there. Close that. Now if I were to bring that up, desktop, If my laptop weren't geeking out, I'd be able to pull it out real quick. It's not giving me the, well, let's go sort by date. There we go. Here's your sizing report. Comes through across like this. It'll give you the generator selection, the site load requirement summary, site requirements, project information, generator performance summary on the unit that was picked. It'll give you all your load profiles. And if you had steps, it would actually separate them into steps for you also. So that's the Kohler detailed sizing report. All right. Now, if I wanted to save this, I would save it right here. It saves it right to the application. I can also download the project as a PSCW file. I can also send the project to somebody else via email. This person receiving the email will have a project copy in their account. So whenever they log into the software, the Power Solutions Center, it'll come up with the list of projects in work, and one of those on the top will have a brackets around it. That would be the project that somebody else has sent you. So you can share this back and forth between accounts in the application. And here you also have the option to copy the project. That's a very basic rundown of the sizing software. You can also screenshot this and print out your one line. I've had people do that already. That's pretty much everything for an introduction to the sizing software. If you guys have any questions, or even if you need us to run sizing software here at Winter Engine, feel free to get a hold of us. I will put my email along with any of the social media accounts and stuff up at the end of this video that you can reach us through. And thank you very much.